Okay, hello everyone in a new video. So we have reached the final part of chapter 1, which is the chapter of lenses and the first unit of optics. Then now we will continue solving problems related to this chapter. So problem number 4, document 1, they mentioned the document, so now I can use it. Shows to a scale 1/5 the optical axis x prime x of a converging lens L, its object focus f, a luminous ray SR. F is the focal length of L. So number 1, they are telling me that O is the optical center, justify. Notice that the luminous ray SR consists of two parts, in which SO is the incident luminous ray and OR is the emergent ray. So SO emerges without deviation along the emergent ray OR, and this is because it's passing through the optical center O. So let's say that an incident ray passing through the optical center emerges without deviation for this reason, then O is the optical center. Okay, we cannot say that O is the optical center because it's the intersection between the optical axis and the lens L, because here we don't have the lens L. So now in number 2 they are telling me redraw using the indicated scale the figure of document 1 and place the lens L. So okay, let me do the drawing here at the top. So the direction of propagation of light is taken from left to right, and whenever we need to redraw, we always start by drawing the optical axis at the center, having the same direction of propagation of light, which is from left to right. So this is x prime and this is x. Now let's consider that this point to be the point O. Now the point F is located 1, 2, 3 divisions in front of O. So 1, 2, 3 on the optical axis. And the point S is located 1, 2, 3, 4 divisions in front of the lens and 2 divisions upward. So 1, 2, 3, 4 and 1, 2, this is the point S. So SO correspond to an incident ray, and we don't forget arrows on light rays that indicate the direction of propagation of light. And the point R is located 1, 2, 3, 4 divisions behind the lens and 1, 2, 2 divisions downward. So 1, 2, 3, 4, 1, 2, this is the point R, and OR is the emergent ray corresponding to SO. Okay, now in the same part they are telling me to place the lens L, and we know that the lens here that we are using is a converging lens. Then we place the lens L perpendicular to the optical axis at the point O, which is the optical center, using the correct symbol of a converging lens. And now finally we need to indicate the scale. Here they are telling me that the document 1 shows to a scale 1/5, and 1/5 means that 5 centimeters along the x-axis and 5 centimeters along the y-axis. So this is it for part 2. Now in number 3 they are telling me specify on the redrawn figure the position of the image focus f prime. So we already know the position of the object focus. We can deduce the position of the image focus f prime because we know that f and f prime are symmetric with respect to O. Here recall that the word specify means that we need to justify. So this is the justification, but this is not enough. We need to locate the point f prime on the optical system. So 1, 2, 3. The point f prime is located 3 divisions behind the lens. And now in part 4 they are telling me deduce f, and the word deduce means here that we need to use the part just previously before. So we need to calculate the focal length f. So in part 3 we have determined the position of the image focus, and we already know the position of the optical center. Therefore we can calculate the focal length referring to its definition, which is given by the focal length is the distance from the optical center to the image focus. And now let's calculate the focal length, which is denoted by small f, which is equal to the distance from the optical center, which is the point O, to the image focus, which is the point f prime. And we don't forget the bar because this distance may be positive or negative. So now f is equal to O f prime bar, which is the distance from the optical center to the image focus. Notice that this distance is in the same direction of the positive x-axis, therefore it's positive. And now we count the number of divisions between O and f prime. We have 1, 2, 3 divisions. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis, and this will give me 15. Since the scale is in centimeters, then the value of f will be in centimeters. So finally f is equal to 15 centimeters. Always all quantities in physics must have a unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. So now in part 5 they are telling me that trace with the justification the path of a luminous ray. So 5.1 parallel to the optical axis. So 5.1. So we need to trace and justify the path of a luminous ray parallel to the optical axis, and here by the path of a luminous ray they mean an incident luminous ray. Okay, so let's trace first, then we will do the justification. So this is a ray, an incident ray parallel to the optical axis. We know that always incident parallel ray is related to the image focus, so this ray will emerge passing through the image focus. And we don't forget arrows on light rays, incident rays, as well as emergent ray that indicate the direction of propagation of light, which is from left to right. So this is the tracing. Now let's do the justification. The justification is given by an incident ray parallel to the optical axis emerges passing through the image focus and now in 5.2 they are telling me passing through the object focus. So we need to trace and justify the path of a luminous ray passing through the object focus. I repeat, here the path of a luminous ray means that an incident luminous ray. So this is an incident luminous ray passing through the object focus. We know that always incident ray passing through the object focus, it will emerge parallel to the optical axis like this. Okay, And we don't forget arrows on light rays, incident rays, as well as emergent rays. So this is the tracing. Now let's do the justification. The justification is given by an incident ray passing through the object focus, emerges parallel to the optical axis. So this is it for problem number 4. Now let's move to problem number 5. They are telling me consider a lens L of object focus f and of image focus f prime. Document 1, they mentioned document 1, so now I can use it. Shows the optical axis x prime axis of this lens. The direction of propagation of light is from left to right, and AB is a luminous ray passing through this lens as shown below. One of the uses of this lens is a magnifier. Okay, so here we are using the lens as a magnifier, one of the uses. Okay, so number 1, they are telling me that L is a converging lens. Justify. So we can always determine the nature of the lens from its use. Here they are telling me that we can use the lens as a magnifier, or one of the uses of the lens as a magnifier, and we know that only converging lens can be used as a magnifier. So let's say that since a converging lens can be used as a magnifier, this means that then L is a converging lens. Okay. Now in number 2, they are telling me that the points A, B, and O belong to the same straight line. Why? So notice that the luminous ray AB is passing through the point O, and so the incident ray AO completes its path along the emergent ray OB without deviation, and this is because the ray AO is passing through the optical center. In this case it's the point O. For this reason the points A, O, and B belong to the same straight line. So let's say that an incident ray passing through the optical center emerges without deviation, then A, B, and O belong to the same straight line. Okay. And now in number 3, they are telling me that the focal length of L is 6 centimeters. In 3.1, they are telling me redraw using the same scale the figure of document 1 and represent the lens L. So 3.1. So notice that here the direction of propagation of light is from left to right. And whenever we need to redraw, we always start by drawing the optical axis at the center, having the same direction of propagation of light, which is from left to right. So this is x prime, and this is x. Okay, this is the optical center O. Now the point A is located 1, 2, 3, 4, 5 divisions in front of the lens and 2 divisions downward. So 1, 2, 3, 4, 5, 1, 2, this is the point A. And the point B is located 1, 2, 3, 4, 5. 5 divisions behind the lens, and 1, 2, 2 divisions upward. So 1, 2, 3, 4, 5, and 1, 2. This is the point B. Then AO correspond to an incident ray, and OB is its emergent ray. And we don't forget arrows on light rays that indicate the direction of propagation of light. Incident rays as well as emergent rays. And the scale along the axis is given by 2 centimeters. Now in the same part they are telling me represent the lens L, and we already know from number 1 that the lens is a converging lens, so we use the correct symbol of a converging lens, and the lens is perpendicular to the optical axis at the optical center. So this is the symbol of a converging lens. So this is it for 3.1. Now in 3.2 they are telling me place with the justification and F and F prime. So we need to locate the object focus F and the image focus F prime on the optical system. So we can do so by knowing the focal length, and here we know the focal length to be 6 centimeters, and we divide by the scale along which we are putting data, which is scale along the x-axis. This will give me 3 divisions. Then the object focus F and the image focus F prime will be 3 divisions away from the lens. Since the lens here that I'm using is a converging lens and the direction of propagation of light is from left to right, then the object focus will be on the left and the image focus will be on the right. So 1, 2, 3. This is the position of the object focus F, and F prime is the symmetric of F with respect to O. And the justification is given by this. So now in number 4 they are telling me construct and complete the path of an incident luminous ray 4.1 parallel to the optical axis. The word construct means that we need to trace and justify. So we need to trace and justify the path of a luminous ray, incident luminous ray parallel to the optical axis. So this is an incident luminous ray parallel to the optical axis. We know that always incident parallel ray is related to the image focus. Therefore this ray will emerge passing through the image focus. And we don't forget arrows on light rays. So this is the tracing. Now let's do the justification. An incident ray parallel to the optical axis emerges passing through the image focus. And now in 4.2 they are telling me passing through the object focus. So we need to trace and justify the path of a luminous ray passing through the object focus. So this is an incident luminous ray passing through the object focus. And always incident ray passing through the object focus is related to emergent parallel ray. So this ray will emerge parallel to the optical axis like this. So this is the tracing. Now let's do the justification, and it's given by that an incident ray passing through the object focus emerges parallel to the optical axis. So this is it for part 4. Now in part 5 they are telling me document 2 shows two different lenses A and B. Sorry, this must be 5.1. And this is 5.2. Okay, so document 2, they mentioned document 2, so now I can use document 2. Shows two different lenses A and B. In 5.1 they are telling me specify the nature of each lens. So 5.1. So let's start by the lens A. So referring to document 2, as we can notice that lens A is thicker at the center and thinner at the edges, and this is known as a thin edge lens. Therefore the lens A is a converging lens. Then let's write down since a converging lens is thicker at the center and thinner at the edges, and this is known as thin edge lens, then A is a converging lens. As for the lens B, so in lens B, this is the lens and this is the optical axis, and this corresponds to a ray. This is the incident ray and this is the emergent ray. So notice that in this case the emergent ray emerges away from the optical axis. Here the direction of propagation of light is from right to left, and we can know this from the arrows on the light rays. So the emergent ray emerges away from the optical axis, and this happens for a diverging lens. Then let's say that since the emergent ray emerges away from the optical axis, then B is a diverging lens. So this is a converging lens and this is a diverging lens. And now in 5.2 they are telling me deduce which of the lenses A or B is of the same type of L. So 5.2, the type of L is a converging lens. A is converging while B is diverging, therefore A is of the same type of the lens L. So A is of the same type of L. So this is it for problem number 5. Now let's move to the final problem, which is problem number 6. The overhead projector is a device made up of a lens L that forms an image on a given screen. The aim of this exercise is to study the properties of the lens L. So number 1, Here they are telling me that is a device made of a lens L that forms an image on a given screen. So the image is being collected on the screen. So 1.1, they are telling me the image given by the lens L is real, justify. So notice that here they told me that the image that forms an image on a given screen. So the image is being collected on the screen, and we know that only a real image can be collected on the screen. So let's say that since it is collected on the screen, then the image is real. In 1.2 they are telling me deduce that L is a converging lens, and the word deduce means that we need to use the part just previously before. In part 1.1 we have specified that the nature of the image is real, and we know that only a converging lens can give a real image. Then let's say that since only a converging lens can give a real image, which can be collected on a screen, then L is a converging lens. And now in number 2 they are telling me that f is the object focus and f prime is the image focus of L. The focal length of L is f is equal to 3 centimeters. So 2.1, draw with real dimensions the optical axis x prime x and the lens L indicating the direction of propagation of light. So notice that here they didn't specify the direction of propagation of light, so we take it as a default from left to right. So here, in other words, we need to construct the optical system of the lens L, and whenever we need to construct the optical system, we always start by drawing the optical axis at the center, having the same direction of propagation of light, which is from left to right. So this is x prime, and this is x. Then we need to place the lens L perpendicular to the optical axis at the center, and the nature of the lens here is a converging lens, so we use the convenient symbol. This is the lens L, and the intersection between the optical axis and the lens L is the optical center O. Okay, and now we need to indicate the scale. Here they told me with real dimensions. So real dimensions means that 1 centimeters along the x-axis and 1 centimeter along the y-axis. So this is it for part 2.1. In 2.2 they are telling me place the foci f and f prime, knowing that f is the object focus and f prime is the image focus. We have that the focal length f is equal to 3 centimeters, and since we are putting that along the x-axis, we divide by the scale along the x-axis. This will give me 3 divisions, and because the direction of propagation is from left to right and the lens that I'm using is a converging lens, then the object focus will be on the left and the image focus will be on the right. So 1, 2, 3, this is the position of f, and this is the position of f prime. So done for part 2.2. In part 3 they are telling me on the drawn diagram construct the path of a luminous ray. So 3.1, parallel to the optical axis, and the word construct here means that we need to trace and justify at the same time. They told me a luminous ray, which means an incident luminous ray. So let's trace an incident luminous ray parallel to the optical axis. We know that always incident parallel ray is related to the image focus. This ray will emerge passing through the image focus. And we don't forget arrows on light rays that indicate the direction of propagation of light. So this is the tracing. Now let's do the justification. An incident ray parallel to the optical axis emerges passing through the image focus and now in 3.2 they are telling me passing through the optical center O. So this is an incident luminous ray passing through the optical center O, and we know that this ray will emerge without deviation. So this is the tracing. Now let's do the justification. An incident ray passing through the optical center emerges without deviation. And in 3.3 they are telling me passing through the object focus. So this is an incident ray passing through the object focus we know that always incident ray passing through the object focus, it will emerge parallel to the optical axis. And we don't forget arrows on light rays. Now let's do the justification. An incident ray passing through the object focus emerges parallel to the optical axis. So we have finished problem number 6. That's it for me in this video, guys. By this we have finished this chapter. Hope it was beneficial for you guys out there watching it, and see you soon in another one.